Good morning, my lovely nines. Right, buddies, here we go for our next lesson or our second lesson in the simultaneous equations unit. I think you're going to really like this lesson because what we've done so far is whenever we've had two equations like this that are together, like we've had an x plus 5y equals 11 and an x plus 4y equals 10, if you wanted to figure out where the two lines that they make hit one another, we used to have to draw a graph of it. Do you remember from last time? Here, I'll see if I can even find a picture for you. Do you remember that from last time, what it looked like? So we did stuff like that, and we figured out where the two lines would hit each other. But, yeah, which is what we did. But that's a bit of a palaver, isn't it, my lovelies? We don't really want to draw a line every single time because you have to guess a little bit where they meet one another. And it's just a lot of effort to draw the lines. And wouldn't it be better if there was an easier, faster, algebraic way of doing things? And guess what, buddies? There is! And that's what we're going to do today. So in your books, my buddies, please put the title Simultaneous Equations Algebraically for me. Cool. Now, here's what I'm going to get you guys to do, and you're going to have to lay it out exactly like me because I'm going to make you guys so ace at this, it's going to blow your mind, but here's what I'm going to get you to do. Please write two equations, these two equations here, one atop the other, just like I've done here. So this one on one line, and then this one on the line under, okay? So just like how maths always is written downward, and then you put other questions next to them, these guys here, it's critical that they're written one under the other, okay? Now, here's what we're going to do. We're actually going to figure out what the values of x are and what the values of y are at the point where these two lines, because you could imagine that they'd be lines if you use the cover-up method, so where the points of, we're actually going to get the points of intersection of these two lines, but without drawing a single picture. And here's what you're going to do. Have you got it written down yet? Okay, cool. Next to the first one, buddies, I want you just to put a 1, and next to this one, just put a little 2. What you're doing with a circle around it, because what you're doing is you're just naming each one. So this is equation 1 and this is equation 2. Now here's the thing, if you look at the first one, it's not actually possible to figure out what x is equal to because there's a y as well, right? So if I made x the subject, then it would be x equals 11 take away 5y, but that doesn't tell us what x is because there's still a y in it. Now, the same deal on number 2. I still can't figure out what x is in number 2, because if I made x the subject, it would become 10 take away 4y. So it's still not cool. Do you see what I mean? You can't actually know what number they equal to. And same deal with y. We can't figure out what y is equal to either, because there's two variables in each equation. So what are we going to do, my buddies? Well, we're going to use a process, my lovelies, that is called elimination. A-T-I-O-N, there we are. Elimination. And here's how it goes. Pretty much, my lovelies, our goal is to get rid of one of the two letters, okay? So we either don't want any x's to be in our answer, or we don't want any y's. And the way that we do this is we are either going to add these two equations together or subtract them. So here's what you do. Start by drawing a line underneath, and then you have to have a little think, and you say, if you compare the x with the x and the 5y with the 4y, is there something I can do here? If I add these two equations together, for instance, will any of the letters go away? Well, if I added them, I'd get x plus x, which is 2x, and 5y plus 4y, which is 9y. So actually, buddies, adding them isn't going to work. But what happens if I subtract them, folks? Well, check it out. If you subtract these equations, you just subtract them kind of the matching letters. If I go x take x, that actually makes nothing, doesn't it? Yeah, everyone follow? So from the first one I did x, I'm subtracting the equations, so I did x take away x, and that made 0. Now 5y take away positive 4y, that's the same as 5 take away 4. Well, that's just going to be y, so it's going to be plus y. Now on this side then, you're going to go 11 take away 10, and you get 1. So in other words, y is 1. By God, where those two equations meet, or where those two lines would meet, y is actually equal to 1. How exciting. Cool. But that's only half the battle, because now we have to get what x is equal to. Well, how do you do that? Well, always like this. You write the word into, and you're going to put this y either into the first one or the second one. And it makes no difference. You'll get the same answer, so just pick whichever one your heart desires. Pick whichever one is easier. So I'm going to pick 1. So let's put it into 1, and let's do it. So here we go. Copy the x out from equation 1. Yeah, so copying that x to there. Then you're going to go plus 5, but rather than writing 5y, we knew that y was 1, right? Get me, my buddies? Yeah? Instead of writing y, we're actually going to put this. We're going to put an open bracket and a 1. And that's going to equal 11. Now, in case you didn't see it, buddies, here's how it works. This bit here is this bit here. Cool? And you knew what y was. You said that y was 1, and that's the 1. So can everybody see that all I did was make a substitution into that? So now we're left with x plus 5 times 1, so that's just x plus 5, equals 11. And you just make x the subject. Take 5, x is equal to 6. And that is the answer to our simultaneous equation. X is 6, and y is 1, like a boss. Now, when you do it, I won't actually make you write them out separate like that off to the side. It's just okay just to have it in line like this. Okay, so it's a bit to get your head around. So what I'm going to do is I'm going to do one more completely with you, and then I'm going to encourage you to try one on your own. So here we go. Second one. Copy this out, please, before, and I'll maybe talk you through it a little bit more. So copy it out for me, my buddies. It is 2x plus y is 21, and x take away y equals 6. So copy that one out for me, please, buddies. Cool, and now that you've got it copied, here we go. What's step 1 again, my folks? Yeah, that's right, you label them, 1 and 2. Cool, what's step 2, buddies? Well, yeah, you draw that line underneath, you're right. Okay, step 3, what do we gotta do? Well, in step 3 is actually the hard thinking step, the hardest step of the whole thing. You need to decide if you'd like to either add these two equations together or subtract them. Now, in the last one we subtracted. I wonder what we'll do in this one. The only way to know, my folks, is you do this. You look for what letter will go away if I add or subtract. Well, not the x's, because they don't have the same number touching them. This one has a 2. And this one has a secret 1, or no number at all. So you're not going to be able to make x's go away, but we can make y's go away. Should I add these two together, or should I subtract? What do you think? Well, yeah, you're right if you said add, but I bet not everybody thought add. I bet lots of you thought subtract. But let me show you why, and then let's see if you get it. Okay, so to start with, let's see what that makes. You get 2x plus x, so that's 3x. And on this one here, and this is why it was add and not subtract, are you ready? This is y plus negative y. Okay, plus negative is just the same as minus, so this is y take y, which of course is nothing, and that's why we add them. Now on the right hand side, 21 plus 6 is 27, like a boss. Okay, if it were subtract, it would be y take minus y, which would be y plus y, which is 2y. That's why we had to add and not subtract. Cool, so this just turns into 3x equals 27. So x equals, yeah, 9, you got it. Okay, now that you've done that, what's the final step? Yeah, that's it, you pop it into whatever one you want. So you just write the word into, and I fancy equation 2 this time, just because I think equation 2 looks a bit easier because it's smaller numbers. So here we go, x was 9, so I'm going to write 9 for x, so I replaced x with 9. Take away y. Is equal to 6. Cool, cool, cool. Well, actually, I think I picked a hard one. I should have picked equation 1. That's okay, though. I'll show you that it works. Take away 9 from both sides. Take 9, and then you're going to be left with negative y is equal to negative, what's that, 3? I think that's right, isn't it? 9 to, yeah, it is that. Okay, but it's awkward, so I got a minus y. So my way wasn't a great way of doing it, but I'm going to times both sides by minus 1. If you times both sides by minus 1, you're just going to get y equals 3, like a boss. And that's the answer to this question. So I hope that you're okay at it. I hope that you've kind of got your head around it, even though it's a few steps. So one more time, what you do is you label the two equations first, draw a line underneath them, and you just have to decide, are you going to add them or are you going to subtract them? And that's what your goal is to do. Okay? So here's one that I want you to try all by yourself. Cool, are you ready? So you know what to do. label them, line under them, decide if it's add or subtract, get what the letter is equal to, pop it into the other one, and boom, you've simultaneous equationed. It'll feel really easy after you've done a few of them, I promise. So you ready? You're doing this all by yourself without me, okay? 3, 2, 1, go. Okay, buddies, and you're back. Let's see how you got on. So here we go. First step first is label them. 1, 2. Second step second, you draw a line under. Now, what did you guys choose? Did you choose add or subtract? Well, I hope you chose subtract, because you would have spotted that if you did x take away x, the x's go away, and that's why you would have picked subtract, because that's the one that gets rid of the x's. So x take away x, well, that's 0. And check this one out. 6y take positive 3y. Okay, take positive is the same as minus, so it would have just been 6y take away 3y, which is 3y, positive 3y. Cool. 20 take 11 is 9. So 3y equals 9. So y equals 3. Like a boss. Then I hope that you wrote down into, and I hope you just picked whatever equation you want. I'm picking 1 because why not? It makes no difference in this case. Only hard ones it makes a difference for. And here we go. X plus 6, because I copied that. Now instead of writing y, I'm going to write a bracket. I'm going to put a 3 in it. Cool? Equals 20. Please don't just write down 18, because that is what it will equal. And please don't write 6 times 3, because if you wrote 6 times 3, you might not be making it clear that you're making a substitution. So that's why you want to use these brackets like that. It makes it look amazing. Okay, so x plus 18 equals 20. Take 18 off both sides. X equals 2, like a beast. So I hope that you're okay at this. I hope you're getting your head around it. Cool? Now, here's me being a bit assuming that you're going to be brain boxes, so fingers crossed you do feel like a brain box. But if not, don't worry, I get to see you in person next week, so we'll make sure that you're pro at these anyway. But hopefully that's okay. In the same lesson, though, whereas I usually stop now, I'm going to go for one step harder. So, as a subtitle, my lovelies, can you please put the title, The Fun Ones, for me? Okay, now these ones here are a little bit harder, lovelies. And the big difference, can you spot the difference between these ones and the other ones? Well, yeah, the difference, if you spotted it, is that you cannot subtract them or add them to each other and make one of them disappear and make one of the variables disappear. So in this first one here, buddies, if I added them, or just on the left-hand side only, if I added them, I'd get 7x plus 7y, and that hasn't got rid of either of the two letters, has it? If when I added them, it didn't work. If I took them away, I'd get minus 3x, and I'd get minus 1y. So there's still x and y in both. So these are a little bit trickier. There's an extra step to them. And here's what the extra step is. You're going to be good at this too. It's not too bad, I promise. Here's what you're going to do. Label them again. Always, always, always the same first step, 1 and 2. Now, once you've got them labeled, once you've got 1 and 2 labeled, here's what you're going to do. Put a little multiply by each one. Okay, a little multiply by the 1, a little multiply by the 2, and check it out. It hasn't worked because they've not had the same number touching the letters. So that was a 2, that was a 5, this was a 3, that's a 4. They're not the same. But there's a cool, sweet trick way of getting them to be the same. And here's that trick, buddies. What can I times the first equation by in order to make it so that the x's, for instance, match up? Well, if that's 2 and that's 5, what's the number that 2 and 5 both go into? A small one, if we could. What's a small number that 2 and 5 both divide into? Well, yeah, 10. You've got it. So here's what I can do. See that 5? I'm going to times the first one by that 5. See this 2? I'm going to times the second one by that 2. Because if you do that, if you just copy out, if you make it so that they have the same first number by doing this trick with the 2 numbers at the start, and you could have done it with the 3 and the 4 as well, well, what will happen is, check it out, these equations change. If you times this whole top equation by 5, 2x becomes, well, 2 times 5 is 10x. 3 times 5 is 15, so this will be plus 15y. And then you'll get 9 times 5, which is 45. So the top equation, 1, has become that. Now 2, though, when you times it by 2, 5x times 2 is going to be 10x plus 8y, and 2 times 19 is 38. So our nice small equations in 1 and 2 have become these monstrosities in 3 and 4. Now, what are we going to do with the 3 and 4 now? Well, actually, buddies, it's become normal. So can you see that they both have a 10 at the start? Well, I can do the regular old tricks like you just did a moment ago. You can subtract them or add them because the numbers are the same. What would you like to do, subtract or add? Yeah, subtract, because they both start with a 10, so they both have the same number. 10x, take away 10x, well that's nothing, that's naught. Yeah, ready? 15y, take positive 8y. 15y, take 8y is just going to be positive 7y. Now the final thing, 45, take 38, is going to actually equal, I hope it's 7. It is 7, that's brilliant. Which means 7y is equal to 7, which means y is 1, like a boss. Cool beans, it's working the same as it did before. Now to get the second part, to get this all finished off, all we have to do is this, my folks. You're just going to take your y and you're going to put it into one of the other two. Okay, into. Now here's the thing, you have 4 equations here now, 4 of them, it's a lot. 1, 2, 3, 4. Well, for sure equation 3 and 4 are hard, right? They've got bigger numbers. So I'm going to bin off both those. I'm not putting it into 3 or 4 because they're both hard. So which one looks the very easiest to us of 1 and 2? Probably 1. Like, you'll get the same answer no matter what one you put it into. But if you pick the easiest one, you're less likely to make a mistake. So let's put it into 1. We'll copy the 2x out. 2x plus 3. But y is 1, so we'll put a 1 in a bracket next to it. So it's 3 times 1 equals, sloppy, equals 9. So 2x plus 3 equals 9. Take 3 off both sides. 2x equals 6. Divide both sides by 2. X equals 3. And shaboosh! You've just done the hardest possible type of simultaneous equations. Oh yeah, in your very first lesson that you've learned it, you've already done the hardest type. The only extra trick, my buddies, was making the numbers the same that are touching the coefficients, okay? Or make the numbers that are the same that are touching the letters, I should say. So you times this one by 2 because this one led with a 2, so you times the second equation by 2. This one led with a 5, so you times the first equation by 5 because our real trick was we wanted 10 to be the same on both. Cool beans? Okay, final question that we're going to do in the video. I want you to pause it. I want you to try this one by yourself. I do realize this is tricky and a big ask, my lovelies, but I do think you can do it. So even if you're a bit stuck, I will explain it in a moment, I promise. But even if you're a bit stuck, I want you to have a go without me, okay? So every single person, you ready? Pause the video, go. Okay, my buddies, and you're back. Let's see how you did. So step 1 should have been labeling. 1, 2. Cool. Now you looked at them and you said, okay, 2 and 3 don't match, 5 and 2 don't match. That means I have to do the extra trick. Now, I'll bet you most of you did this, timesing this one by 3 because that was a 3, and so you times this by 3, and then timesing this one by 2 because you said that was a 2, so I'll times by 2. I'll bet you that's what you all did. Cool. Then you tripled the whole top equation. So it was 6x, because that's what 2x times 3 is, plus 15y, you times that by 3 as well. Oh gosh, here we go. 16 times 3, 10 times 3 is 30, 6 times 3 is 18, so that's 48. Cool beans. Now on the bottom, here we go. 3 times 2, 6x, which you know you've done it right because it matches now, minus 4y, oh, it's going to be a hard one, equals 10 when you double that one. Cool. You label them then, 3 and 4. And now it's going to work because since you made the x, the number touching the x the same, the x's can go. So should we add or subtract? What did you guys do? Well, I bet subtract. Now, you would have done subtract because you would have thought to yourself, if I start with 6x and I take away 6x, I get 0. Now check this one out. This is where you could have made a mistake. That's why I said it's a tricky one. You ready? 15y, take negative 4y. 15y, take negative. Take negative is the same as plus. 15y plus 14, or plus 4y is 19y. Cool, cool, cool. And here we go. 48, take 10, is 38. So 19y is 38, which means that y equals, and it actually does go in evenly, it's 2. Yeah? Y is 2. And here's what you'd have done. You'd have taken your 2 and you'd have put it into 1 or whatever, one or the other. I'm going to put it in equation 1 because it's got smaller numbers. I look happy. It's not got a minus sign in it either. That usually makes it easier. And here we go. 2x copied out plus 5 copied out, but y was 2, so we'll put a 2 in a bracket next to the 5 equals 16. It's this equation with that number put in. So 2x plus 10 is 16. Take away 10 from both sides. 2x equals 6. X is 3. Like an absolute boss. Now, I hope you found that lesson challenging. I hope that you enjoyed it and have your head around it largely. That would make me really happy. And here's what I'm going to get you guys to do. And I'm really going to catch people out who didn't watch to the end of the video. I've attached this worksheet. It's simultaneous equations, elimination 2. But here's the thing. I only want you to do, I don't know, maybe 6 questions in total. So I'm going to write this down. Do 6 questions in total. And choose them from question 1 and question 4 only. So there's 12 questions, question 1 and in question 1 and question 4. There's 12 questions all together, but just do 3 of each. I'm saying 3 of each because I want you to make sure you're trying a variety. So you could do, for instance, that one, and that one, and then go down and do that one, and this one, and this one. Cool, see what I mean? So just choose any of those questions you want that you should be doing. These actually have the answers attached to it as well, so the worksheet has the answers too, but the answers are just single numbers, so you should use them to check if you're right. So if you got it right or not, you can check, but it's not got the workings out. Now, if you solve them with no workings out, I'll know that you've cheated, and I'm not counting the homework as being done. Okay, so no copying the answer scheme, even if you're like, oh, I can do it mentally, which is what you guys, well, maybe not you guys, but which is what I've always heard in the past. When I first taught this to year 9s, they're like, I can do it mentally, I don't have to show any steps. You can do a few of them mentally, buddies, but at the same time, though, I don't want you to, and I also think I've picked ones that are tricky enough that you won't be able to do them mentally. Cool? So with steps, looking just like the ones that you did, I want you to go through and choose any 6 of these 12 questions. Cool beans, buddies? Right then, well, I'm really looking forward to seeing you in person, and really, really, really good work on all of the online learning that you've done. It's a real challenge. It just shows how resilient and well, how clever and how self-driven you guys are, how self-motivated you are. So awesome work, my awesome 9s. Look forward to seeing you soon. Submit it as one PDF onto Google Classroom for me. And that's it from me, my buddies. See you next time. Bye, buddies!